So at this point, you have seen the basics of HTML. You've seen the basics of how HTTP plumbing works, if you want to think of it that way. You've seen how requests and replies work. You've seen the idea of cookies and how they can be used to create essentially a correspondence between otherwise stateless HTTP requests from the same user. Now it's time to sort of put these together and see how a web app framework provides abstractions that make it easy to deal with all of this machinery. Some of the machinery is sort of hidden from you entirely. For example, you will very rarely, if ever, have to deal with low-level HTTP request and reply syntax like we did when we showed examples using curl on the command line. Sometimes it's not hidden from you, but it's made much easier to use. So the idea of a cookie that can be used to pass state back and forth, well, it would be nice if you just had some state that you identified that you wanted to pass back and forth, and you didn't have to worry about the mechanics of how to sort of package all of that into a cookie and get it back later. So we're going to start with a tour of a very simple app in Sinatra, which is a much simpler web framework than Ruby, but all of the basic ideas we're going to see here, we're going to see in a more flexible and more powerful form when we do Rails instead. So understanding the concepts in Sinatra will give you a good foundation, and basically all of the same mechanisms will apply. So here's the world's simplest Sinatra app. It's a Sinatra app because I have loaded the Sinatra gem or library, and I've created a class that inherits from the Sinatra base class, which means I inherit all of the functionality in the framework. One of the things the framework gives us is a set of methods with names like get and post and put that are designed to match incoming HTTP requests. In other words, what's the route that is coming into my app? And here's a rule basically that says if the HTTP method is get, and the route is just /, which is usually the root route of the application, here is some code to run. Now remember that in Ruby, every block of code has a value, and if there's no return statement, the value of the block of code is the last expression that was executed in that block. In this case, the expression is just the string hello world, and that seems a bit weird because this says when our Sinatra app receives a get request of / from the browser, the only thing it's going to send back is this bare string hello world. There's no HTML view wrapped around it, but let's see what happens anyway. I've got the app running over here, and I will open a new browser window. And because the app is listening on port 9292, because that's where Sinatra apps listen by default, that's where we're going to go. And sure enough, there's the string hello world. Why does this work despite the fact that there's no HTML or anything around the string? Basically, it's because in the old days, the web browsers had to be very, very forgiving. They will basically try to consume and display just about anything you give them, even though what they really would like is a nicely formed HTML document when a web page is rendered. Sinatra has a way of letting you set up various HTML views or pages, and I have set one up already in the views subdirectory of my Sinatra app. I have a view called hello.erb, and there's not a lot going on in this view. But the view does try to get an instance variable called, there's not a lot going on in this view, but it tries to grab an instance variable called @someone. So I'm going to have my block of code in Sinatra actually set that up. And now I've got to tell Sinatra, instead of just sending back the bare string, render that template. In other words, go grab that HTML, and anywhere that you see this notation, this %, basically evaluate the Ruby code inside there and replace that part of the contents of the template. This is called embedded Ruby, and it's why this file has the extension ERB. It basically means grab the file and look for places where this notation introduces a Ruby expression, substitute the result of evaluating that expression into the thing being rendered. So in order to do this, I will tell Sinatra to render the ERB template named hello. And if I now go back to my web browser and reload the page, you can see that I got the Sinatra demo. In other words, I'm now rendering an HTML view as opposed to just sending back a bare string. Now, one thing that is a little bit subtle and you may not have noticed is you hopefully remember when we talked about HTML that what you're seeing here is not a complete HTML page. There's no doc type declaration. There's no meta information in the header. There's nothing like that. And in fact, that's because another of the abstractions that Sinatra and many other web frameworks provide you with is essentially a wrapper that can go around any of the HTML views. So for things like the HTML document type and some other boilerplate that you might want to have that basically has to be part of every view you render, that can be abstracted into another file that in Sinatra is called layout.erb. And at the place where the layout.erb uses a yield, that's where the view being rendered by your app is actually going to be substituted in. By the way, this is a particularly cool use of the idea of yield the same way that it's used in iterators. What's actually happening is that we're rendering the layout file, and the layout file yields to allow something else to render the actual view. Cool little Ruby tidbit. So in this case, in fact, we can make this even look a little nicer. This is the default Ruby style sheet, or the default Sinatra style sheet, which doesn't do much for me. But I like Bootstrap. I think it's a great framework for sort of getting an app off the ground. And I am going to use the super duper easy, let's grab the link code from the Bootstrap homepage so that we can incorporate that style sheet into our app instead of the default one. And if we now reload the page, we get what I consider a marginally cleaner looking design. And again, if we added additional views to our app, all of those views would sort of be wrapped in this layout template before they get rendered. So that's why, even though what it looks like we're rendering is just sort of a partial piece of HTML, it gets wrapped by the whole thing afterward. Now let's go back to our app up here. We could probably do something a little more interesting if, instead of having a fixed string that's rendered all the time, what if we allow the user to control what that string is? So for example, suppose I change it to match the route /hello/ I don't know, some value. So this is another aspect of Sinatra's syntax, and when we see Rails routing mechanism, which is more complex, the same convention will apply. A token in the URL that begins with a colon is like a wildcard. It is going to match any substring in the URL, and it's going to make that value available to Sinatra in a special data structure called params, which quacks like a hash, meaning you can expect it to do all the things hashes can do, but the way that it's populated and managed is a little bit different and special. And in particular, one aspect of how it's managed is that as the URL arrives and Sinatra parses it to figure out if any of our code blocks match it, those wildcard tokens will get put into the params hash as keys with the appropriate value. So for example, if I go to /hello/Armando, then the variable I'm assigning in my Sinatra controller or in my Sinatra app now is getting its value from the params, which got their value by parsing the URL and realizing that /hello/Armando does match /hello:value with the value placeholder being set to that string. And so that's what got rendered in the view. By the way, what happens if we try to go to a route that Sinatra does not have any handler for? Well, we get a cute error page. And if this were a real app, we would probably replace this with something a little bit more informative and less flip. But that's the basic idea. And by the way, just to show you a very useful technique, I'm going to put a debugger statement, bybug, right here at the moment that Sinatra has matched the route and gets control of my app. This is a very useful way to inspect, as you're writing code, whether the world looks the way you think it's supposed to look. Kind of one of the principles of debugging is find the first place in the code execution where your expectation of what happens does not match the reality of what happens. And one way to do that is by putting a debugger breakpoint and sort of stopping and looking around. So suppose we do that. We'll go back and use our other route again. And this time, if we go back to our terminal window where I ran Rails server, you'll see that we're actually stopped in the middle of the controller method. And I can pretty print the params hash and see that, yep, Sinatra has successfully collected the part of the URL matching the wildcard. It's put it into the params hash with a value. The key value is what I would expect it to be. And since I'm happy with that, I can say C to continue. And of course, by this time, the request has timed out because I took so long to debug. But that's okay, because the goal was to show that the debugger is a valuable way to stop the action anywhere you want, look at the values of things, and verify that things are behaving the way you want. What else does Sinatra provide you with? Well, we said that the goal of a framework is to sort of wrap some of the basic abstractions of HTTP HTTP and HTML so that you don't have to manipulate them directly. One of the ones we talked about was the idea of a cookie. In other words, something that the server can use to hand some piece of state back to the client, and it's the client's job to pass that back to the server on subsequent requests. And because HTTP is stateless, this is a way that we can keep track, for example, of a user doing one request after another and sort of going through a workflow that is stateful. So because that is a very common idiom, Sinatra gives us a way to manage that. And again, pay attention because the way that Rails does it is very similar, but adds more flexibility in certain regards. We're going to have Sinatra enable the sessions mechanism, and we're going to add one more route. Basically, we're going to hold on to a piece of state representing the user's choice for setting, let's say, who is going to be addressed by hello world. We're going to put that into the session, which quacks like a hash that persists across all requests. So if we do that, for example, I might define a new route called set. And just for fun, I'm going to give the wildcard a different name since it doesn't matter what it is. So now, if from the browser I visit /set/some string, that string is going to get matched as the wildcard name, and I'm going to put that into the session hash. And once that's done, I'm going to send the user back to the root route. We'll change this back to the root route, and we're going to make the root route retrieve that value, not from params anymore, but from the session. So what have I done here? What do we expect to have happen before we actually try it? If I go to this route, then I will store in the session whatever was substituted into the URI as the value of the name token. And then I will immediately redirect. That means I'm starting an entirely new HTTP request cycle. I'm telling the browser, that was all right, but where you really wanted to go was here. And I'm going to send the browser back to the root route. Now remember, when I've sent the browser back via a redirect, all the variables that I might have set up in my previous action here are gone. It's like we're starting the world all over again. But I'm relying on the fact that the magic hash of the session has preserved the value of session name, and then I can pull that back out and assign it to this variable. So let's see if this actually works. I will, again, go back to the browser, and this time I will say set to Michael, which means that if everything goes well, I will end up in this block of code, and that the session will now store this parameter value. It will redirect me back to the main view, which is going to render this very simple HTML snippet. And now I should see the value that was stored in the session persist there. And indeed it is. And that no matter how many times I reload that page, which you can quite see I'm doing it by I'm hitting a refresh, until I go back to that set action and set it to something different, the value is preserved. So what's going on with the session? As you probably have already guessed, the session is really kind of like a wrapper around cookies. And in particular, the session will serialize whatever you try to put into it, and that will get stored as the value of the cookie. Now, serialization basically just means we have to put the thing into the format of a long string that can be reconstituted later into the original Ruby object. In principle, any object that you can describe in Ruby, in other words, an instance of a class or anything like that, an array, every object can be serialized, but the serialized representation of the object might get pretty long if it's a complicated object. So serializing a string, no problem. Serializing a small hash or a small array, no problem. Serializing a complicated class that has a lot of nested classes and other things might end up with a very long serialized value. And that's important because the HTTP specification defines a maximum length of how long a cookie string can be. And if you try to serialize an object that is larger than that, your app will start sort of failing in very mysterious ways. The moral of that story, and we have said this before, is most abstractions are leaky. The session acts like a magical hash that preserves its content across requests, but that abstraction is based on using this underlying mechanism called a cookie. And if you're not aware that that's what's happening, it is possible to abuse the abstraction and to use it in a way that breaks the rules of the thing being abstracted. In other words, it's possible to have a session value that even though it's serializable, it's too long to fit in a cookie, and then things break. The abstraction no longer behaves the way that you expected it to. So it's worth keeping in mind. So what are some highlights of this sort of very abbreviated tour of the Sinatra framework? A Sinatra app basically just declares explicitly which routes it recognizes. It's got Sinatra methods like get and post and put that match a URL that might have some colons in it, some tokens that will be parsed out into this quasi-magical hash called params. Sinatra will parse the route. It'll try to match it to a block of code in your app.rb. It will populate params with any of the wildcards that match the URL. And although we didn't explore this particular aspect of Sinatra, if I had created an HTML form in Sinatra, the form fields would also be keys and values that appeared in the params hash. We'll see an example of that on our next tour of Sinatra. The views in Sinatra are really just HTML, but they use embedded Ruby templating. That means that you can embed Ruby expressions that get evaluated at runtime, and in particular, instance variables that are set in the action of Sinatra, in what I'll call the controller method, the part that actually receives control when your route is parsed. You can set instance variables in there, and they will be available to the view. Now, from a sort of pure object-oriented perspective, this might strike you as weird, because if you think for a minute about object-oriented design, it's hard to imagine that the blocks of code in my Sinatra app.rb are somehow members of the same kind of class as the thing representing a view. I mean, they're just too different from each other. What actually happens in this case, and this happens in Rails as well, is that the designers of Sinatra thought it would be nice from a programmer's point of view if you could just set some variables in the controller method and have those variables be available to the view, even though it's a completely different class. Ruby allows doing this through some really neat mechanisms around metaprogramming, about which you can read more in the book. But the bottom line is, yes, this is a violation of traditional orthodox object-oriented programming, but it's in the service of making things more convenient and making life a little more streamlined and pleasant for the programmer. So I am okay with it. In addition to having views that are selected by saying, ERB, please render this, there's also an optional view called layout that, if it's present, is used to wrap every one of the other views. So that's a convenient place to put things like style sheets and other code that have to be common to every view rendered by your app. Maybe you would put some branding in there, for example. We also saw the session, which behaves, or I would say quacks like a hash, whose contents are magically persisted across requests. And it does this by essentially packaging the stuff you put in there into a cookie. When the browser passes that cookie back into Sinatra, it will unpack the objects in the session and make them available to you through this hash-like thing. And in fact, I encourage you to try this out. In your browser, most browsers have a setting where you can temporarily disable cookies. You can try this demo app. The GitHub repo is public. The URI is right there. You could try running the app yourself and seeing that if you disable cookies, the ability to preserve that name across invocations will go away because the browser is no longer passing the cookies back to the server. So that's a trip through a very simple web framework. Next, we'll do a slightly more complex app also in Sinatra. And again, the concepts we're learning here are going to be useful when we move to the much more complex Rails framework. You might ask why Sinatra exists at all. Really, it's because some microservices are small enough that they can be described just fine in Sinatra, and they do not need a lot of the extra power and flexibility that comes with Rails. So part of being a good SaaS designer is picking the right tool for the job. We're going to introduce a couple of tools for web frameworks, and this is the first of them.